So when you're seeing these formulas in the book, we have now a present value formula in the book, and we also have this future value formula, and it starts to feel like we have all these formulas and they're going to get confusing. But I really want you to realize that these are in fact the same. So if I start with my future value formula for simple interest, then if I know P and I know R and I know T, so I substitute these values all in, yeah, I can get A. But what if I don't know P, right? I don't know that P value, but instead I know A, R, and T. Well, I could still solve for P. So I can do that in general by just dividing both sides of the equation by 1 plus RT. And since this is a whole factor that's common, this is dividing something over itself. This is just a big 1. And so I'm just left with P is equal to A over, so I'll just write it over here. P is equal to A over 1 plus RT. So this is the present value formula, but it's really just the future value formula rearranged. Now you should have been able to solve sort of formulas like this in the past, so this shouldn't be a new skill, but I want you to see that they're really the same. So if you, after you read example 5 on page 228, which I'll let you do after watching this video, you'll see that in fact there's no real reason for the present value formula. You can always just use the future value formula, which is what I do here. And I just substitute the given values in example 5. Again, I'll let you go back and look at that in a minute. And so when you're substituting all these values in and then you solve for P, you're going to get exactly the same value as if you use this present value formula and substituted in those same values, A being 32,000, 0.09, and T was 412. So if you substituted all those values in, you're going to get exactly the same result. So is this computation, this above equivalent to the work done for example 5? And the answer is yes. It's just algebra used to solve for P. And so yeah, absolutely, it's the same thing.